Hey guys, and welcome to /X Games. So this is going to be part one of Native Studio networking, and this is really exciting because I'm going to be taking everything that we did with HTTP DLL2 networking, and I'm going to be incorporating it into the Native Studio networking so you can use this on any platform you want. And the cool thing is, because we're going to be starting this basically from a bare bones basic project, it means we can take this wherever we want and we'll always know exactly how we got there. It's really cool stuff. So as always, I've got my server on the left and my client on the right, and as you can see, there's pretty much nothing in here. No DLLs, no extensions or funny magic. It's all built-in stuff. So I've got this object called object message in our server and in our client. And basically what it's going to do is just tell us what's happening. When a player connects, object message is going to be created, and it's going to have a little message saying player's been created. When someone leaves, it's going to say someone's left, or when the server's created, it's going to keep telling us what's happening, just so that you know that whatever code we implement, we can see the result in more than one way. So that's really cool. So to start this off, I'm going to be going into object message and showing you what exactly it does. It's exactly the same on the client and the server, so don't worry, I'm only going to be showing you once. So here we have a create, and in the create we are saying that we have some alpha, we have a message that's set to blank, and we are saying put this about 5/6 down the page and about in the middle. And then what is the step doing? Over here, the step is saying, well, decrease your alpha, destroy it when it's invisible. And I think it's just going to be drawing out the message as well as whatever the alpha is. So very basic. Something fades in, it says what it is, and then it fades out and destroys itself. So it's not hanging around there forever. So that is the message. Pretty cool stuff. Okay, so I'm going to start with the server on the left. We're going to be creating our controller object, and then we're going to be creating clients to join. So let's go over here, let's add an object. Object controller has no image, and it's going to have a create event where we're going to define and initialize some variables to create the server. So this is pretty much step one, creating the server. We need a network type, we need a port, we need a max players. I'm creating these all as temporary, it doesn't really matter, this create event is only being run once. Yeah, so we'll never need these again. We're going to have a buffer size. We're going to need a type. We're going to need something called a buffer alignment. I'll go into what these all mean in a moment. Okay, so network type. Let's go over here. We want network socket TCP. So here we've got Bluetooth, we've got TCP, we've got UDP. So I'm going to focus on what TCP and UDP are. TCP is the most reliable form of communication that we'll be using. So basically I send a packet, the packet gets received on the other end, and then I also get a response back saying the packet was received, so I don't send it again. So it kind of can take a while because we're always making sure that our packets are getting there. With UDP, however, we're just spamming whoever we're sending messages to, we're just spamming them a whole lot of messages. If they don't get there, it doesn't matter. We actually want speed over reliability. But for our project, we're going to be creating some sort of shooting game. We want to make sure that everyone's having a good time. So things that should be reliable need to be. So in this case, we're going to be using TCP for the main game elements right over here. So that's simple. Our port is going to be 50,000. I have set that up previously for HTTP DLL2, so that's still all set in my router. Max players, I'm set to 32. Buffer size, 1024. This is in bytes, so 1024 is 1 kilobyte. You can fiddle around with that depending on how much temporary storage you need, because the buffer is just used to temporarily hold the data while it's being moved from one place to another or manipulated. So we need to make sure that when we're getting information from our client, 1024 bytes, which 1 kilobyte is enough for that. You can change this to 2048 or whatever, it doesn't really matter, depending on your requirements. Cool, so the buffer type is going to be fixed. There are other types. Actually, if we go back here, we might be able to see them. Here we go, we've got buffer grow, so depending on how much data you get in, it keeps increasing in size. Notice that if I set it to 1024 bytes and we set it as buffer grow, if we get an incoming packet that says it needs 1025 bytes, then the new buffer size will be 1025. It doesn't get reset to 1024 between messages. So do notice that growing means it'll eventually be the size of the greatest message received. What else do we have here? Buffer wrap, that's the other one. So what buffer wrap does is, if our buffer size is 1024 bytes and we get a message that requires 1025 bytes, then what it'll do is it'll fill the 1024 bytes with the first 1024 bytes of the incoming message, and then that last remaining 1 byte will be wrapped around to the beginning position. So you will lose data in that way. So choose a buffer type that's good for you. I will put links in the description where you can go and read more about these. Basically, every game that you make is not going to be the same. Requirements change. So for this example, I'm just going to be using bare bones basic fixed buffer size, all these kind of things. Even alignment, I'm going to use 1 because we don't know exactly how this project is going to be working. Again, I'll put a link in the description. You can read up on buffer alignment. It's pretty much just how data is stored in the buffer. Different data types perform better with different alignment. So as we go on, maybe we'll change the alignment to one of the others. But for now, let's just put it as 1 because we don't really know what will be coming in the future. Cool, so now it's time to create our server. Server equals network create server. There we go. And here we're going to pass in our stuff, network type. And then we're going to pass in our port and our max players. Cool. So now it's time to create a buffer. We will be making use of 2 buffers, the read buffer and the write buffer. The write buffer, which is the buffer that sends things to the clients, is going to need to be used by everyone. So I'm going to make that global. That's what we're initializing here. And then every time we get a message from a player, we're just going to create a read buffer on the fly. Cool. So using the information that we have above, you can say buffer create. We have the buffer size. What's next? The buffer type. And the buffer alignment. Cool stuff, guys. There we go. Technically, we have a server. So now let's create a list of sockets. And these are unique identifiers for clients. So each client that joins, we get a socket from him. We can store it in a DS list. So let's do that now. And the cool thing about this is whenever we want to send a message to a specific player, we can find him in this DS list and then send stuff off. And then, only he'll get it, which is really cool. So that's why we need this collection. And then I'm going to have... So we can use object message here. This is the first usage of object message. We'll be doing this sort of thing throughout the project. And in this case, we need to first make sure that object message doesn't exist. So let's destroy itself if it does. And here we can save our notification. It's pretty much just going to create object message, give him some sort of string, some sort of text, display it, destroy it, whatever, just so we can see what's happening. Var notification equals instance create, and we want to put this, it doesn't really matter because he's got his own code, object message, and we can say notification message equals server is up. Cool. So as soon as we see this message on our screen, we'll know the server was created successfully. Cool stuff. Now, always when you create things, remember to immediately make sure they get destroyed when they should. So we can add an event here, other, game end, drag in some code. So things we need to destroy, I think it was the server, our global buffer, and our list of player sockets. So let's first destroy the server. Cool, done. Next, let's destroy that buffer. This is the write buffer. Cool. Next, it was the DS list. We have to use DS list destroy, not delete. Remember, delete is going to remove a position in the DS list. We want to destroy the whole thing. Cool stuff. Okay, cool. There we've created things. We've destroyed them. Everything's great. Cancels each other out. Nothing's hanging around for later. Now I'm going to create a draw GUI event, and it's going to pretty much just show us how many players are connected. Drag in some code. Let's set up some things here. Draw. I think we want to draw in white. So we can have a black background, so white will do for now. Then we're going to draw text. 5 server status. This is just going to tell us if the server has been successfully created. Server is greater than 0. When the server is created, it returns a 1, which means success. So as long as that's greater than 0, we're good. Next, draw text. Actually, I want to make this bigger. There we go. And 520 total clients. So remember that DS list called sockets? Well, every time a user connects to us, we put his socket in that collection. Every time he leaves, we remove it from that collection because there's no point having a connection to him. So ultimately, if we query the size of that DS list, we'll know exactly how many users are connected. So we're going to string the DS list size. And what DS list was it? Was sockets. Good. Cool beans. There we go. So stands, clans. We're golden on that front. Cool. Now here's something that you might have never used. We're going to add an asynchronous networking event. So whenever we get something in that has to do with networking, it's going to be sucked into this event. And the cool thing about it is this event's going to contain all the data that we need to determine what kind of event it is, what kind of data there is, and then we just take that data and store it in our temporary local read buffer. So we first need to grab the event type, which is automatically stored in the DS map called async load. So here we're going to read from this DS map. Find value. Async load. Yeah, is it async load? Yes, it is async load. And its type. Yeah, cool. So now we'll have an event type, so we can switch on that. Let's create our skeleton. So there's a couple different types of events that we can grab in here. There's the connect, when a client connects to our server. There's the disconnect, where a client leaves. Third one we're going to be using is the event where we get some data. Cool, so let's write them out now, just as a skeleton, and then we'll come to them later. Case, network. There we go. Break. Case, network, type, disconnect. Break. Case, network, type, data. Break. Cool. So there we have our skeleton of the networking event. So let's start off with the easy ones. Connect. So what does it mean for us? Well, we know someone's trying to connect. We need to take his socket, which automatically gets stored in this event. There'll be another value we'll find in async load. And we take that socket and we're going to store it in our DS list, our local DS list sockets. And once we've done that, I'm going to create that object message again and give it a message saying a new player has joined. That's going to be really exciting when we get to see that. So var socket equals DS map. Find value. I'm just going to steal this. Change that to socket. Then DS list add. To which collection do we want to add? Well, it's the sockets collection, and we want to add the socket that we just received. Then I'm actually going to go into our create, and I'm going to steal this because I don't want to keep having to repeat it. I guess I could have just created a script and then just shoved it in there, but I'm too lazy to do that now, so we'll just keep putting it in. Okay, so server is up is going to say a new player has connected. Very cool. So that's connect. There we go. All good, all good. Let's do disconnect now. We need to make sure that we're actually removing from this sockets collection when a player leaves, because we don't want any residual data that we no longer need. We want to make sure that everything's efficient and optimized. So I'm going to grab this again. get in the socket of the player that left. See, he is sending us his information. Then before we can remove it from the DS list, we need to find out its position, because if you look here at DS list, I think it's delete, it needs an ID and a position. Okay, so that's what we need. Let's put this down here. So we need to find the position. So var find socket equals DS list find. We have everything we need to find it. Oops. Let's find index. Where do we want to look? Well, in the sockets collection. What do we want to look for? Socket. We want to first make sure that we're actually getting something back. For some reason, if the player disconnecting doesn't exist, we don't want to be destroying someone else, because obviously something horrible has gone wrong. We don't want to make it worse. So if that's greater than 0, or greater than equal to 0, then we can actually delete it. Otherwise, we're going to get like a index out of range sort of explosion. Delete, and we're going to look in sockets, and we want to delete the find socket index. And then again, let's grab all of this, and we'll paste it over here. So we've done it, see, there it is. Paste it over here, and this is going to say a player has left. Cool. So we need to make absolutely sure that this piece works. So later on we'll check. If it doesn't, then we're going to have to just reevaluate this area and make sure we grab the right index and we're deleting that. Cool beans. Very good stuff. Let's make this bigger. Alright, so we've done the connect, we've done the disconnect. Let's go down here and do the data type. This is the meat and potatoes. We're going to be dealing with this pretty much for the entire rest of the tutorial series. So when I was doing research into the native studio networking, I was checking out some other tutorials from some other guys, and I was doing a lot of reading. I noticed what they did was, here in the network type data, they created a script with naming somewhere along the lines of script handle incoming packets. And what it did is it took in a buffer and a socket. And then we went to that script, and there we did all our stuff. So we took that buffer apart and read what it was all about. So I think that that's a great idea, because we don't want this networking event to become too crazy and big and long. It's going to make debugging it just hell. So I'm actually going to follow that standard over there, and we're going to just shove all our data that's coming in into a script and let it do the rest. Cool. So first we need to create a local temporary buffer that deletes after this event, and then it's going to just have the data passed into that script and then delete itself pretty much. So var buffer, don't confuse global.buffer and buffer, two completely different things. This is a read buffer, the other one is the write buffer. We don't want to destroy the write buffer until the game actually ends, so don't get confused with that. DS map find, if I can just grab this. And we're grabbing the buffer from async load. Cool stuff. Then again, we are grabbing the socket of whoever's sending the data. And that is stored in the ID key. So firstly, that buffer that we created, well, we need to take it to the very beginning of the data, make sure it's right at the beginning, so we can use buffer seek. Which buffer do we want to seek to the beginning? Well, buffer that we just created. Buffer seek start. And 0. And then we're going to pass things into the script. So now let's go ahead and create the script. Script handle incoming packets. Remember, we're passing in our read buffer, passing in some information about this player. Say OK. Create scripts. There we go. And it's going to need to grab the buffer. It's going to need to grab the socket and the message ID. Now, if you are familiar with my HTTP DLL2 networking series, you will know the way networking works. So basically, we make the connection. It's all great. And then every time we want to do something, send a tag or an ID. So once we have that tag or that ID, we'll be able to determine exactly what that message is all about and then grab its data accordingly. So these are going to all come through into the script as arguments. except the last one, which is going to be buffer read from that buffer that we just read in, and it's going to be an unsigned integer 8, the smallest type of unsigned integer, right over there. So whenever we're sending a tag or a message ID, it's always going to be of type buffer U8. So whenever we receive data, the very first thing we're going to read is the tag or the ID. So when you're sending data, make sure you send the tag or the ID first, because the order in which we send it has to be the same as the order in which we receive it. Cool. So that about wraps up the server for now. Let's save that. I'm going to jump over here to the client where we're going to be doing some other things, and then later on we'll hit the server again to finish up some touches, and then back again to the client. And then we'll get to test it, so that's going to be really fun. Cool. So in our client, I'm going to create object controller. Let's keep everything standard. We've got object controller on the client and one on the server. And it's going to have a create. We're going to initialize some variables. Let's make this big-ish. Yeah, let's make it full screen. We're going to need a socket. We're going to need an IP address to connect to. We're going to need something called isConnected, which just determines if we're connected or not. We're going to need a global buffer. So in this very first part, the first thing I'm going to be showing you how to send and receive is the player latency. We want to see how long it takes for us to send and receive a packet. So I'm going to create a variable here called latency. And it's going to be 0 right now, and we're going to be updating that and displaying it on the screen. It's always going to be updating, which is really cool. So that's going to simulate the sending and receiving of packets rapidly. And if we can get that latency working, it means that not only have we been able to successfully connect a client to a server, but we're also able to communicate with that server. Alright, for socket, we need to make sure that the socket here matches the type of the server. So that was a TCP. Network socket TCP. Cool. Then the IP address here is going to be, because I'm connecting to localhost 127.0.0.1. At a later stage you can change that, or even get it from the user. Then isConnected equals network connect socket, and at the bottom it says there our URL is our IP, and our port is 50,000. Very cool. Global buffer is going to be buffer create. It's 1024 bytes. It is fixed type. And our alignment is 1, exactly the same as the server. Very cool. And I wonder if I have... Oh, I don't have that object message in here. Let's just grab it from the server. Here. Yes, go back to our client. Paste it down here, and that's going to say something like, I'm thinking client initialized. Cool, so when we see client initialized, it means we've been able to connect to our server. So again, like we did with our server, when we create some stuff, let's make sure we're destroying them when we leave, or when the game ends. So in this case, game end, we need to destroy the socket. And we need to destroy that buffer. Now one thing to notice is that here in our client we have something called socket, and here in our server we also have something called socket. So the difference is that when we're in server land, the socket is going to represent a connection to a client. When we're in client land, the socket is going to represent the connection to the server. See that? That's why in the server we need a collection of sockets, whereas in the client we only need one socket. We only ever need one. We're not communicating with other clients directly, just one server. So that's why we just have the socket. Cool. So let's stay focused. We're deleting those. Then, as before in our server, we need to create an asynchronous networking event. And I'm going to go to server and I'm going to steal some code. paste it in here. Things we don't need. Well, we don't need connect. We don't need disconnect. Those are all gone. We just need network type data. And a lot is pretty much the same. We are reading stuff in to a local temporary buffer. Then we don't need this. We're just seeking to the beginning of that buffer. And as before, we are feeding it into a script we're going to create called handle incoming packets. So let's go to scripts. Let's create that now. And it's actually pretty much the same. There we go. So let's keep that there in the back of our mind for now. Let's create a draw. GUI event. This is to draw the latency that we are going to be receiving soon. Set color. Also see white. We're going to draw text. Let's put it at 5.5. It's going to be latency. Our string latency, and I'll show you how we get this variable sorted. Cool. Then let's go back to script handle incoming packets. And the thing is that the difference between the server-side handle incoming packets and the client side is that the client doesn't need the socket. So let's make sure we go back into the networking event and not pass it in right over there, because we've only got a buffer. We've only got a buffer available to us, so that's all we're passing in. Cool. Let's go back here. That's all set up and ready. Cool. So I'm going to save everything. So we're at the point in time where we've created a server. We have created a controller in our client side to connect to that server. And at this point in time, we will have a connection. So, well, what do we want to do with this connection? Let's send the server a message saying, hey server, I'm here. I want to know how long it's taking me to receive a message. You know, what is my latency? So in our object controller, every step, which is our roam speed is 60, if I remember correctly. Yeah, roam speed is 60. So 60 times a second. We are going to be saying, I want to calculate my latency. So we're going to say update latency. Cool. So buffer seek, global to buffer seek start. Cool. So we're going to seek to the beginning of our global write buffer. Oh, this needs to be 0, sorry. Then we're going to be writing a tag or an ID to this. Very, very much the same to the HTTP DLL2 networking series, so everything should be quite familiar. And the type is going to be an unsigned 8. And what we're going to write? A 1. Cool. The very first tag is going to be a 1. I'm going to start at 1. And then what do we want to write? Any other information to this buffer? Well, of course. We want to write a unsigned 32 data type, and it's going to be the current time. So to work out our latency, we're going to take our time now, send it to the server, and the server is just going to act as a messenger, as it pretty much does all the time, and it's going to be sending this current time back to us, and then we're going to compare what the time was to what the time is now, and the difference is going to be our latency. And then lastly, network send packet socket. See, where we're sending it to the server, and the server is pretty much stored in the socket. That's our connection to the server. And we're going to be writing the global buffer. And here we need to say the size. Well, if we use buffer tell, which is a terrible name for working out the size of a buffer, but okay, that's what it's called. So buffer tell. So that's going to be the size of the buffer. So we're telling it exactly what to expect. Cool. So in actual fact, that's everything we need to do for the client. We're going to hop back over to, let's save that, let's save this. Hop back over to the server. And now the cool thing, because we are handling our incoming packets in the script is we don't have to go to the controller anymore. We can go into the script, and here we need to say, well, we need to switch on message ID. And the first case was a 1. And what I like to do is put a comment here. Latency request. Cool. And another thing is, if you're going to be sending a tag, make sure that obviously you're receiving the same tag, and when you're sending a response, send that exact same tag. It's just so that when you're tracing the movement of packets through your game, you know exactly where they're going, where they're coming from, and which sections of code are breaking, if they are. Cool. So when we get in a 1, we are going to be saying var time equals buffer read buffer 30 u32. It was u32. Remember, we need to keep the same data type. That was the u8 that we first read, that we first sent. We're reading that first always. And then the next one was u32, which had the current time, so we're storing it in a temporary variable called time. So we can say buffer seek global buffer. So this is our write buffer. We're getting to the beginning of it. Getting to the start, 0, bam, buffer write. You'll see what I mean over here. We want to write to the global buffer. We want to write a tag of 8, u8. And we want to write a 1 again. You can even say message ID if you want. And that'll write exactly the same message as was received, but I'm just going to put a 1 there just so that we can actually see what we're sending. Next, to write to the buffer, I need to write a u32, which is pretty much the same data type as time. Same data type as we received time in. And then now, send back to player who sent this message. See? Pretty simple. Network send packet to the socket. See? Socket is our unique connection to the player. So if we send it back to the same person that requested it, well, that pretty much wraps up that. Pretty simple. Send it back to the same person. What do we want to send? We want to send the global buffer. And then we also need to use buffer tell. And there we go. Pretty much just like that, we have relayed the message back to the player. Now, remember, we're going to have this collection of sockets. So if you wanted to send this message to absolutely everyone, you can just loop through every single socket in the collection of sockets, and everyone will get the message on their side. Pretty awesome, eh, guys? Cool. So now if everything is correct, it's going to be sending a 1 back to the client. And again, here we're going to go into handle incoming packets. We're going to switch on the message ID, case 1, and again I'm going to say latency request var time equals buffer read buffer. That's the buffer we're passing in, so we're reading from that buffer, and what we need to get from there is the first instance of a u32 data type, which is going to be our time, and we're going to update our variable latency to current time minus time. Cool, so that difference is our latency. Cool stuff, guys. We've actually completed everything. This is everything we need. Created the connection, updating our latency, sending and receiving packets. So before we run this, I'm going to be just going through some stuff quick, just so that you know exactly how the flow works. So we have our controller. It creates an instance of a server. Then once that's up and running, networking event is going to be firing off, and that's going to be waiting for events to happen. So here we are as our client. We create a client instance. Our controller creates a connection to the server based upon these variables, and once that's done, the networking event of object controller on the server is going to be hitting this switch, and it's going to hit this, which tells us that there is a new connection. We're going to store that socket in our collection of sockets. We're going to pretty much just tell ourselves here that things are happening, and there we go. It's going to sit. So every time we need to connect, so every time we need to respond to a request or something from that user, we're going to use this socket. And when he leaves, we just kill that connection. Cool. So every time he does something, for example, in the step event, he's going to be requesting to get his latency, and in this case he is sending a tag of 1 and the current time to us. In this case the socket is our server. It's going to be landing up here in incoming packets. Well, firstly it's going to be going through the networking event and get to the data type, where we read in the data from the client. We read in the client's unique socket, and we're going to get to the beginning of this read buffer and pass everything to our script to handle it. When it gets to that script, it's going to be grabbing that time using buffer read, and we're going to be getting to the beginning of our global write buffer. We're going to be writing the same tag, which in this case is a 1. That's what we're getting. We're going to be writing the variable that we received, and there we go. Send it back to the same client, and he's going to get it in his handle incoming packets. But before it gets there, obviously it's going to be going through his networking event in the one and only case, network type data, right over there. And when that comes into here, we're going to find out that it was a 1. That means it's a latency request. We're going to grab the time and update the player's latency. Cool. So now what I'm going to do, I'm going to save this, and I'm going to create 2 instances of client and obviously 1 instance of our server, and we'll see what happens. Alright, so before we test this out, we just need to make sure that both our rooms in the client and the server have an instance of object controller. Bam, over there. And here, game world of our client, objects, controller, right over there. Cool. Save everything. So now let's fire up with the server and multiple instances of the client. Cool. Server's up. It says server is up, player joined, a new player has connected. That's what we got. So our server says status is 1, which means it's all good. We've got 1 client connected, so I'm going to create another instance of a client, and we're going to see that go up to 2. Okay, so I'm going to fire up another instance here of our client. Watch, total clients is going to go to 2. It's going to say a player has joined. Let's do this. Play. Alright, so let's watch. Latency is being updated. That's pretty cool. So we are sending and receiving packets. Everything is running well. And there we have it. A new player is connected. Here we have his own latency. Client's initialized. It says 2. So now if I tell one of these guys to leave, on our server it's going to say a player has left. Boom. A player has left. And if we do it again, another player has left. Pretty cool. So that about wraps up our part 1 of Native Studio Networking. I'm going to call this one Making a Connection or something like that. This is the very first part. There's going to be many more parts following this one, where we're going to do all kinds of fantastic things. This is the time that you should be sending in your suggestions, as we did with the HTTP DLL2 networking series. You guys, my fans, are going to be directing this series. Whatever you want, I'm going to try and accommodate as best I can. So we're going to create something fantastic in the end. It's going to be thanks to you guys. And hopefully along the way we can all learn exactly what it takes to make a multiplayer game using GameMaker Studio's networking. So thanks for watching. Please feel free to comment, rate, and subscribe. If there's any part of this tutorial that you did not understand, you can leave a comment and I can help you out, or someone else that also knows what's going on can help you out. Please check the description for links to all kinds of topics that I didn't go into that much detail, so you can check them out on your own. If you like this video as well as many of my other GameMaker tutorials, please check out my Patreon campaign. If you can donate a few bucks a month, I do appreciate that. It keeps me going. You can find links to the project files right in the description. And you can also follow me on various social media networks, Facebook, Twitter, Instagram, all those kinds of things. Links are all in the description. Cool beans. So I can't wait to make part 2, and every part after that is going to be a really exciting series, and I can see a lot more people following this one than the HTTP DLL2 series, because this is just far more cross-platform. So thanks for watching, and I'll see you guys for part 2.